Hello, this is Dr. Marion Carroll, and I'm at South Central Louisiana Technical College in Reserve, Louisiana, production technology majors, and this is general chemistry that we are studying, and we're up to lecture 9, and this is one of the most challenging topics that many first-time chemistry students struggle with a little bit. I think primarily because the word stoichiometry is not something that you come across in everyday life. But essentially, stoichiometry is a study of quantitative, that means amount, quantitative measurement between the amount of reactants used in a chemical reaction and the products formed in a chemical reaction. So essentially anytime a reaction were to occur, for example, let's use sodium hydroxide and sulfuric acid. Alright, this is a acid-base reaction. You're going to form sodium sulfate and also water. Alright? And so we're going to talk about how we determine, based on a given amount, for instance, if we're asked to, we're given 2.8 grams of the sulfuric acid. Based on that, we ought to be able to calculate how much product could potentially be made, how much of the second reactant, sodium hydroxide, will be required, how much water will be made, simply by knowing the amount of one of the reactants in this chemical reaction. So we'll actually do this problem, and I'll show you the steps involved. Alright, let's look at stoichiometry simply. And I think I used this example in class. If I'm going to make, as part of my product, I want to make a loaf of bread. One loaf of bread. Okay? In order to do that, I'm going to need 1 can of beer plus, let's make this 2 cans. 2 cans of beer plus 1 bag of potato chips. Yeah, now, don't go out and try to figure out how to do this. Many can guess what the beer would be for, helping the bread to rise. The chips, I don't know. There's probably something to be said about providing the, not the yeast, but the flour, potato flour. But nevertheless, we're going to need 2 cans of beer plus 1 bag of chips to make 1 loaf of bread. Alright, so the stoichiometry is 2 plus 1 gives you 1. Alright, 2 cans of beer, 1 bag of chips, 1 loaf of bread. Now if I had 24 cans of beer, and I had 11 loaves of bread, no, I'm sorry, 11 bags of chips, how many loaves of bread can I make? Alright, you can intuitively figure this out. If I need 2 cans and 1 bag to make 1 loaf, alright, I got 24 cans, so I need 2 for each loaf. So I ought to be able to make 12 loaves just by looking at the number of cans I have. And we need 1 bag of chips to make 1 loaf, so by looking at the number of bags of chips I have 11. So I can make 11 loaves just by looking at the bags of chips. But how many can I actually make? Well, because we can only make 11 loaves with the chips, 11 loaves is all that can be made, because this is what's referred to as a limiting reagent. A limiting reagent, G. So I can only make as many loaves as I have the least amount of reactants. So the least amount of reactants I have are the bags of chips, because I can only make 11 loaves from just considering the bags and excess beer. If I had excess bags, more than 11, I could make 12 loaves, because I had 24 cans of beer, and 2 cans for every bag of chips will give me a loaf. So this is the nature of stoichiometry, and in this case we also have what's called a limiting reagent. But how much of each reagent giving us product is essentially what stoichiometry is. And the fact that we operate chemical reactions in moles helps us out a lot, because unlike the beer and the chips, those are 2 different units of measure. Can of beer is liquid, we're talking maybe a 8-12 ounce can. A bag of chips is obviously weighed in grams or kilograms, and they are sometimes a different number of ounces depending on the type of chip it is. So we're dealing with different types of measurements, and so they're incompatible in terms of one-to-one relationship. However, with chemical reactions, moles, in every case, 1 mole, no matter what the chemical is equal to what? 1 mole is equal to 6.02 times 10 to the 23rd atoms. And so whether I have a mole of sodium hydroxide or a mole of sulfuric acid, I should write this, 1 mole, 1 mole. Whether I'm dealing with 1 mole of sodium hydroxide, alright, this is considered, when we're talking about a compound, this is considered all together. So the sodium hydroxide molecule, or or compound, we have 6.02 times 10 to the 23rd sodium hydroxide molecules. Molecules of NaOH. And we also have 6.02 times 10 to the 23rd molecules of sulfuric acid. So here we have molecules reacting with the same number of molecules reacting with the same number of molecules. So that anytime we're talking in terms of moles, we're dealing with a measurement that's of equal value. A mole is this many molecules. A fraction of a mole will be a fraction of this many molecules. All right, and so we're going to go into part 2, and we're going to do some stoichiometry problems, and I'll provide you with the steps, and I'll also talk a little bit about the kinds of reactions that I'm using in the example, and this should help you recognize combination reactions, or a decomposition reaction, or a double displacement reaction. So it's always good to recognize that type of reaction in the simple ones that we will be doing, because as it gets more complicated, then you have a basic frame of reference to follow. All right, I'll see you in part 2.